Okay.
Okay. And then I can share again. So, okay, so we covered DR awareness and hosting capacity, and now we're talking about more applications, active network management, and maybe a little bit of flexibility. So we will see which one I think you might be more interested. But okay, so active network management. What is the basically benefits or overview? So let's say you have some constraint on the network, and you have some traditional methods such as, for example, it depends on the violations. It could be voltage or current, like ampere violations. ANN can utilize both like the traditional methods like capacitor or voltage regulators on the transformers, or the DERs with some flexibility that it allows to us to do some changes on that. And it's real time. So it would send the real time the information to the field, and it takes the real time information, of course, before to start. So there are like automatic way and semi-automatic way. So I will explain how does that work. Automatic means like closed loop. So it we get the information and like analyze it and suggest the set point already and send it through. Semi-automatic is like, yeah, it gets the information, it just to give a suggestion, but it doesn't send it. It just shows the results for the user. So okay, so there is one concept as merit order list, or MOL as abbreviation. So merit order list, like let's say you have multiple DERs on the network. You have generally many of them, let's say. Um, so maybe more than one of them can be used to mitigate that violations. So which one you go first, which one you go second, which one you go third. So this merit order list is like list. So from one to whatever number that we have on that feeder, it starts from the top and engage that one. And then if it's enough, doesn't go to the second one. If it's not enough, go to the second one, third one, so far, so on. And this merit order list can be updated and provided to our system as well from somewhere else. Okay. This one, in this version that we have, we are mainly working on the MV. So like we need to model the batteries and stuff on the MV. In future versions, 3.11, we are planning to enhance this to the LV as well. So that's like a limitation on this version. And okay, we have two way to check the verification constraints. One, through SCADA limits and measurements. I will explain it when I do the demo. And the second one is running load flow. So the good thing for the first one is you don't need to tune all the network, but like the limitation is like you cannot comprehensively check all the elements. Load flow, when you run it in the background, it shows results for every single point of the network is under load flow. So is it section or on the lateral or on the main feeder or whatever it is. When we use SCADA, it actually still uses the topology, so it knows like when it starts and when it like goes through. So it uses topology, but a state estimation, of course, it knows the flow of the the current and power flow. Okay, the other benefit is, let's say, what does flexibility means? I a bit covered it this morning. Let's say you have a 5 kilowatt solar or battery or whatever. So rather than just totally stop if there is a problem, we just say, okay, I give you this flexibility. You can play in this range and it's fine for our system. So instead of 5 kilowatt, you can go up to 1.5 kilowatt or 2 kilowatts, whatever it calculates. It is safe for the rest of the network. So the order of intervention. So like we have passive element. When we say passive elements is, for example, a voltage regulator or capacitor. You don't need to, basically it doesn't cost for the end owner of that asset to do some change, because when you generate, so you need to, basically it costs. When you reduce the load, so if you are planning for selling that to the other to the people, you lose money if they tell you constraint. So, but the passive elements are like not impacting the price in a way, like in a cost. So, but like it has to um, do some change, like tap position. So it first try, if it's selected, again, we can select or not select. It tries to mitigate the problems with the passive elements. All right.
So let's try with like BBO.
Yeah, something like CVDO. Yes, something like CVDO. Yeah. And okay, and when those things happened, we can also do a merit order list. We can also do switching, like transfer load from one feeder to another feeder. So it could also suggest that kind of switching as well. That's the first one, actually. So then we are using a contracts limit. So I will go to this one in depth in the next slide. So maybe is that clear here? All right, okay. So what do we need? So, okay, similar to other functions, definitely we need topology if we are using the model-based SCADA. So I think it's kind of common from the previous things that we said in the morning. Exclusion list, what it is. So sometimes you don't want to operate a device for whatever reason, because it's under maintenance, or they don't like somebody tells you not to use it. So you put it in an exclusion list, and then it would not be used for impacting the results. We will talk about our repository database. So far, what we had from yesterday and the day before sessions, we have everything in the network model. Network model, we were showing to you most of it in the DMD and network builder. So those signals that I was showing to you, or battery itself. But for DRs, because nowadays the number of DRs getting the number of them is become increased, and sometimes you need to have update them more frequently. And we decided to create a database in SQL for them, and we call it DR repository database. In this database, we put a MOL, as I said. It could be updated automatically or get from another systems. We put the contracts. Contract table, I go to the next one, but let me explain. Like we have few types of contracts. Flexible generation means like you come to some agreement with the owner of that asset that allow you to play with their generation in a limits. So what is the maximum and what is the minimum? So for example, the solar panel, let's say is 5 kilowatts. You make a contract with them. you can play between 2 kilowatts and 5 kilowatts. You cannot go below 2 kilowatts. So that's where the contract minimum is 2 kilowatt and maximum is 5 kilowatt, because they can go up to 5 kilowatts. It's already the rating. The same concept is for consumption. So you might have some big customers that you make some agreements and say, okay, I want to reduce your load if is between this limit. So it's like normally you could go up to 6, let's say, kilowatts. I want to sometimes to just not make it more than 4 kilowatts. And then I send a command to you that keep the limit to 4 kilowatts. They can go between 4 and 0, right? Because it's still within the limits, but yeah, so that's flexible contract. Maybe I share this one. Can you see on the Teams this one, or because sometimes when I was sharing here, it's a little bit small, but this is the relationship between elements in that table. So DER is the elements, right? So it has some attributes. So for example, maximum export limit, maximum import limit. So these are the basic elements. And then the type. So if you what type it is a number. So like 1, 2, 3, 4, 1 is, for example, you can define what is 1, what is 2, what is 3. And then you have a contract relationship with the contract. The contract would be flexible consumption, I just explained, flexible generation, and grid services. This grid services is a bit different from these two. It's maybe, I don't know if there's use case for this one or not. So let's say a battery already producing 5, I don't know, let's say put a different value. Like you have a big battery, it's a 500 kilowatts, okay? And they are running it at the moment, 300 kilowatts and importing. And they tell you, okay, I am doing 300, but I can offer you 100 kilowatt to play with. So means that you can send me command between 300 to 400 on the positive side, and the negative side also you can say between 300 to 200. So you give 100 and we call it offer active power. So it can be a positive number, it can be a negative number. So it's a bit different from the other two. These are absolute value. It's based on rating. This one is based on the amount that is generating at that moment. You know what I mean?
Okay, that doesn't mean like they can like offshore or some offshore the reactive power also, right? Because
This is for
actually
active power.
just for active power.
Yeah.
Okay. So because some like battery can like offshore some reactive power for the grid when they receive the command. So okay.
Yeah, this application is generally is for active power, but yeah, because the companies that we work with, like probably they wanted to have this, and active power was for them more important. But yeah, maybe we can check that. Okay, so this three. So it's a bit confusing at the beginning, but maybe when we discuss and show how it works, maybe you know what it is. So let's say you have a solar panel, solar farm or solar panel. So you probably go with flexible generation. You don't need flexible consumption because you want to just, and then probably this one is more probably useful for like batteries or generators because they can play. So for solar, you are in the maximum. So you cannot more expand more. So always you can just start carefully. So probably it's more usable to use this one. But it depends on like the companies. And then we have like a period. What does period means? I was briefly showing this morning that at different time of the day, how much you can have. This is like just a number. So when I say 100, it's 100. But this one could be, okay, at 9 o'clock is this, on weekends it's like this. Also, like we have a day of week, for example. So you can have multiple contracts. So you can have for weekdays one contract, for weekends another contract. If these are, I don't know if you guys have tariff with the customers and the price is calculated differently in billing. So this could be, yeah, this could be useful in some cases that they have different tariffs and like they might offer you more on the weekends, not on the weekdays. Okay. So there is like a price period. This price will be used to calculate this merit order list. I told you this merit order list can be from outside, it could be fixed. So it could be fixed, you know, okay, this one was on the first to use, but we can, I mean, they're developing something for this one to calculate this merit order present price. The lower the price is, it goes to the top because you want to send command to them rather than the expensive one, right? That was it. And then the R command, which basically, like, okay, we want to say, send the different commands. So this is kind of like, it's not directly used. We have engagement. Engagement, what does engagement means? So you sell, then you have a big battery. Okay, they say, all right, you can use my battery for whenever you use it, you need to register to this engagement. Say, okay, I used your flexibility and I send the command. And when you send the command to that list, it goes to this engagement list. It's a list of things. And when you, next time you run active network management, because it runs periodically, it first looks at which assets I have engaged before, you know, and I disengage them because now maybe the constraint has gone away, right? Maybe the load is now lower, so I can disengage them. So first goes to this disengage the previously engaged elements. So this is kind of dynamic. System updates it and removes it, updates and removes it. And then anything from this one goes to the history. So the one that we need to populate is this PER. We did for this one once. And these contracts. And they can be added anytime. So we have an XML kind of like file format. We put it in a location. And it's not like whether that you want to do it every hour, right? So for this one, probably whenever you have a new DR, you have a new contract, you want to update, you put the file there, and it will be read and go to the database.
So then you should do at the same one for the weather data, because if you have some like folder to us for just put the file or the weather data inside this, and you can read the like some file like this. It's better for convenient, right?
No, because why? Why is different? Because this is like you only update it once a week, once a day, something. It's less frequent. For things that are less frequent, the design of the system is data importing. But that's real time data every 1 hour changes, and we do integration because of that. Mechanism and design is different. Yeah, I know what you're saying. Could be possible, but yeah, this is designed like this. All right, so all right, so here Okay, so this one. I need to check something actually. I think maybe we do because I see the note on the reactive power. You said reactive power. I need to check because the example I have it doesn't have reactive power. Maybe it supports it. I need to double check that one. Sorry for that. I think you said does it use reactive power? And maybe it does. So I need to double check. Probably it's in my notes. So okay. So this is like an example of something we call it zones. So these are different substations. So this side is like high voltage and this one is low voltage. What we call zone, so this is simple zone. It's not connected to any of this. So anything, these are like a bus and they're connected together. We call it one zone. And same as this. So these two are very simple. Sometimes you have two substations and you tie between them. And you might sometimes do. These will be done together because from topology point of view, we are connected and like runs it together. And if in a case that you have one transformer here, between them, this bus tie switch is open. They are not electrically connected, so then yeah, you can say this is one zone and this is one zone. But this one, see that these are parallel, so they are electrically connected. If from one side, yeah, they are electrically connected, but from one side. So, but like, yeah, that's fine. This is engineering. Okay, so this is the concept that we have for this application. All right, so there are some profiles that we use. What kind of constraint we check? So we check for voltage, we can tick or not tick, overload, reverse flow, and we have some deadbands. Deadbands means, let's say you put high voltage as under 10% and minimum 90%. So, and you can put a bandwidth for that, like let's say 1%. If it's still within that 1%
Acceptable limit.
acceptable limit. So yeah, so you don't need to, because if you don't have this, you might send too many messages. Okay, so if we tick this, it will use a state estimation. If we not use it, it will use the measurements. And like when we have this tick, then yeah, we can check this. But if you don't have this, it's not like applicable. These are the switching. I said you can do switching as well. Like what type of switches you can send a command to. Okay. You can select cap changers, capacitor. So this part is when you send the command, okay, you want to know is actually applied and change something. So you check the command is actually done. So this is for measurements. So like you send like cap changers up and down, the measurements will change, and you need to wait to see if the actual measurements are updated based on your command. So you can select or not select that one as well. Maybe I just go back to, okay, so yeah, still. I got one, I think more. Maybe I'm just trying to say when we switch back to the software. Okay, so did I explain this now? Okay, so there is this button in power application setting. You can inhibit triggering ANM. It's the periodic one that it does in the background. So it's like 900 seconds, like a default every 15 minutes runs. These are like checking the measurements violations. So if you want to check the measurement violations, like yesterday I was explaining, probably you were not here, like we need to wait like 75 seconds all the changes settle because they might come from different RFUs and different places. We don't want to send too many messages, so we wait 75 seconds. And then timeout for unstable normal variation changes is like up to 300. So let's say it's keep changing. So then if it keeps changing, we say, okay, up to 300, now we do some action, right? So if it still keep changing after 75 seconds, you wait for 300 more. And this is for emergency violations. Let's say for limit violations, we have limit 1 and limit 2. Limit 2, we call it emergency. If it's more than that one, we want to act more quickly, right? So we just wait only 10 seconds. And this is coordination for freezer, which is probably not the case for you. So we don't want to have that. So okay, so maybe I just go and show this on the software. It might be easier to follow, but like I will double check if I miss something here as well. Okay.
Phải cho cái hoạt động rồi nó gắn không được
Hồi nào
tuyệt vời.
mình tăng cách đăng tiếng rồi đó.
Okay, so active network management is actually, you can access it on here. So this is the one that you need to select, A&M. And then when you turn that on, like select that one, it brings you this menu, and similar to all other applications we have, is hierarchical. I'm gonna go to this Montana, that which I already selected, and so I go to here, right? So, and then this is the substation I want to choose from, right? So, if I right click, there are some buttons here. You can use those buttons, or you can right click and do something here. So this one, if I select, it changes the mode. So disable, don't do anything. Test mode is that semi-automatic, and enable is full automatic. So test mode means like it does calculate, but it doesn't send any command. So it just for user. When you turn that, so you see like we get this completed with warning, the last run, and messages partially resolved, will be resolved. Okay, partially resolved. Now you can say go to the A&M report. I already have it open. So, but okay, so I can either use this or go to here and go to that Montana. Go to the second one. All right, so yeah, so this is again says completed with warning. This is overview of this. It says how much curtailment we have as import increase. Import increase means I can import more, right? And import decrease, I means I can import less. So basically it's kind of generation, right? So if you think about this, this is can be generation, but this can be like, let's say a battery, you can import more, or when you say import less, that means you generate. So these are shown 0 for now, but okay. And then you got some values here. So your initial value is the megawatt that you have measured. So this one is like the value that we have measured from there. and the limits and expected value. And this is some commands that it calculated. So the first one here is everything. So voltage regulator. It says, okay, put the set point to 1011. So this one is here. So you can see the transformer bank here. So it's sending command to this particular one. So yeah, it sends it to this one. Let me just close some of this, which we don't need. So just a little bit. Maybe I close this one that I opened this morning. So all right, so this is the set point for that regulator. This is let's say it says, okay, this capacitor, it wants it to open it. So we want less capacitor because probably the voltage, and the same for this, maybe we have too much wires here. So if I go to the resources, like this is flexible asset. So flexible assets means like things are not DR, let's say. So this is the transformer. So sometimes it cannot use it, and it gives you the reason why it cannot use it. So blocked for remote control. So that means like for this one, we have said do not use to send a command from remote, you know, like the auto not yeah. So I think let me see what signals we have here. Yeah, I think because this is the signal is not good. So you see, this is we have this quality flag there, so it just doesn't use it because of that. So okay, so if this is not available, that's why it's if it's engaged means it is used. So this one we saw here that was used. So engaged, it means used. Not changed. So this one, it was already open and remains open, not changed. But like we had some of them that was engaged, like this capacitor C1374, like is this one. So it just gives you that. And then for the flexible resources, we have this battery. So this battery was 0 and now is didn't change anything and it didn't update it. So maybe I go to that battery, see what's happening here, there. So set points. Yeah, we can, this is active setting. All right, one thing I need to show you is this merit order list. This merit order list, I already populated with some data. So a device can have more than one appearance here. What does that mean? So this battery, it said you can use 100 kilowatt. So first, the system looks if it needs to use it first, or if it doesn't need to. If it needs to resolve something, if there is a violations that this can help to resolve, it will look at this. So positive numbers means consumptions, right? So basically, like let's say you have too much solar, that it's better to use the battery to absorb that generation. So in that case, if we have too much solar and it's impacting the constraints, it will try to do the first with 100. And then if you need more, it goes to get this one. So you can accumulate this, like aggregate this, sum of it. If you need 200, it uses this two. And so far, so forth. So up to 100, 100, 200, 200. So up to how much is it? Like if we sum it up to here, this is the maximum can be utilized. So it's 900. Negative means generation, like if the battery is charged. So firstly, making sure the battery is charged, and then we need to generate power to reduce that consumption. Then it will use this number. Again, it's like aggregation. So it just tries to use first this one. If it worked, that's fine. If it didn't work, it tries to put 200, 300 up to here if we sum it up. So for this element is, and then if you could have mix of this, it could be like something in between. Because why we have this? Because the battery, like owner of battery maybe say, okay, I give you flexibility only for 100 kilowatt for this price. And if you want me to reduce this more, you need to pay more. So that's why we want to limit the impact on the battery as less as possible. So, and maybe you don't have, this is a complicated kind of example. In reality, if the price is the same, they might give only one number. It says, okay, you can play up to 1,000, and we would have just one entry in this one, and we say 1,000 or we want. So this is the, we have this.
So what if when we like create a marriage order for example 100 value 100, that in some cases we just need about 50 kilowatt only. So could we use this but just for 50?
Yes, that's actually a good question. Yeah, so it tries, so first, like if it's too much, it divides it by two, like, and like if it's 100 too much, it divides it by two. So 50 is okay, yeah, use 50. If 50 is not okay, go to like 75 between. So it plays, yeah, it tries only put as much as is needed only. But one thing it would do, so let's say you have a limitation, and that limitation is like, let's say, a value. It tries to keep it as less as 3% of that. Again, like a bandwidth thing. So let's say you want to limit to 1 megawatt. It targets 3% lower than this because of let's say inaccuracy in data, or when you send a command, so in a few minutes maybe it still changes, and then you don't want to try it again. So
Do cái gì thì mình kết nối vô thiết bị đó do cái gì thôi, nó đang hỗ trợ nhiều yếu tố.
Có một cái tên rồi có mỗi lần thời gian rồi đó.
Được chứ. Quyết định thời gian thật chứ không phải theo thời gian. Quyết định thời gian thật, này đang thời gian thật mà. Nó đề xuất cho anh sử dụng nguồn nào các kiểu.
yeah, if you just I just show like some like example. So we need the megawatt here. So like, yeah, so this is the measured value. Maybe I just check the profile library to see what I have there. Okay, my profile library is here. Okay, I'm checking for overload, reverse flow. Oh, we have reactive power here. Yeah, constraint we can have for reactive power too. So yeah, I think reactive power also will be used if it's available. Okay, so this one is, we say only use, but don't use estimate value. All right. So this is the one that we have a battery on it. So this is 4 megawatts is going through. My limit is 5. So this is okay. That's why we didn't have any suggestion in the report. You remember it was 0 and it stays 0. So let's say I want to the limit change or load increase, either we can increase the load or change the limit. So let's say I change the limit. So this 4 is too high, right? So it's going to be too high. I submit this. And then I go to this. If it's automatic, I need to wait 15 minutes and run it again. But like, let's say I trigger it. Yeah, so you see this changed. And then I go here and I refresh. You know, this time you see this one came. So like, okay, I go here. So you see it was initially was 0. It put 1 megawatt to accommodate that load. Because why? Because we had 4 megawatts and limit is 3.6, right? So why put 1 megawatts? Because as I was explaining here, it doesn't look at this because this is for increase, right? These are for like, it goes to 100 is not enough, it goes to 100, goes not enough, and it goes to up to here. So it just, the total of this one is 1,000, and it engage it like there. And then, so this, if this automatic, if it was automatic, it would send that proposed set point to the battery itself. And so contract disengagement. Before this, we were not using this battery, right? Because previous to run this, it was disengaged. Now, if I apply this 1,000, that means I use the flexible resources. So flexible resources was, if you look at here, these are flexible resources, and we could have also curtailments and other things. So it depends on, but yeah, this one. And the other thing you can also see here, so this is merit order number 9. So this row number 9 is basically means it went through here and it applied up to here. So yeah, so this is 1,000, 1,000, 100, 100, 100, 200. That's why all of this is 1,000. So that is, yeah, so this is this. And I can actually just and this is the flexible resources. You see, it just total of 1,000 was used here. And now my limit is, yeah, this 3,000. You might have more. You always, it's good to have a look here because it shows everything. This was for the substation, right? The one I have battery on it is one of the feeders, MS number 1. But it gives all of the problems on the substation because yeah, so this, you see, if you notice, initial value was 4 megawatts, and then it tried to reduce by 3%, but 3% more of this because it's used 1,000. So yeah, you put 1,000, and it's not quite 1,000 because the losses and stuff like that may be a little bit different. So yeah, it's close to 1,000 is what it says. Yeah, clear this one. You can see what it is. To be honest, I think it's maybe you need to play with the system to quite understand all of this functionality. But okay, so at least you get some familiarity on these ones, and you can. And their engagement report. So like, okay, so their engagement report is empty because I didn't run it in the periodic. So let me just, let me go to this one. Let me just do it in like a open loop. Let's, instead of test, make it enabled and then run it. And when I do this, when you change it, you don't need to retrigger. It just takes a bit of time and it runs it, and it might have run it already. You see that the value changed, but this refreshes every, I think, 10 seconds or something. Now you see, again, I need to refresh this to see what happened. Yeah, so this is happened. This is my battery. So this is, I locate this battery and I see the signal. You see the set point was previously 0, now is 1,000. This was sent by the, this one. And like, for example, if you want to check, you know, I think I'm just showing other functionality paper. You see it already. Like you want to see what happened, you just trend it. Okay, so I go to trend. So you see this one was 0 before. Yeah. And then now I changed to 1000 in this time. So now my engagement list, so it's not empty anymore. And for Montana Sky, it says, okay, 1000 active power used. And then you go to the resources. Now you see the initial contract was disengagement, and now is flexible services. It keeps this one. Yeah, because you want to know which one you send the command to.
But I could the system like because it's just like simulation communication with this battery, right? Yes, but how could like they simulate the control command and they change the value of the simulation devices. How could it do it? You maybe have like
there is a simulator in the background for this. Are you saying this? So this is basically send the value to the simulator,
and it changed
it.
the state of the read. So it's very
Yeah. It is there. That's right. So that one maybe it takes a while, but let me just see. Go to the let me see what was the results of this active Montana Sky. So you see, actually, that simulator reduced that 4 to 3, and it's resolved now. Right. Yeah. Okay. I maybe I explained that. Yeah. How this happened. Okay. No, that's actually a very good question. You ask good questions. I like that. So, okay. So I'm trying to show the simulator behind this. So when we opened DND, we had some like different options. So this one was network simulator. All right. So if I go here.
So it's like some kind of the model.
Load flow. It does run load flow.
No, I mean like or the model of your product or something.
Yeah.
Yeah.
Yeah, it's part of our product. So network simulator is part of the product. It's actually in this system that we are demonstrating to you. It has the same model in the network simulator. And like the measurements that you see here that actually are produced by simulator. And that could be because of running load flow in the back. Yeah. So let me just explain it a little bit. In reality, when you go to production, okay, this one is not for that. This is when you have this, and maybe for user training. So we use it for user training too. So if I go like the same battery that we send the command to, let me just make a little bit. Okay, this is EMS. Okay, so let me copy this field, go to here, Control F. Yeah, all right. So here you see the signal is exactly looks the same, but it shows blue. Here you say network simulator. Okay, we have simulation and we have network simulator, two different things. Simulation was I was showing this morning for hosting capacity. Okay, network simulator, I mean, the blue screen is the same, like on the back. You could change that color as well. If you don't want to have this, maybe you might make it a different color. But okay, so this 1000 we sent, it was received by here. And here, like we have load flow profile. So we have told to this load profile that when a set point changes, rerun the load flow, the triggering setting. So if I change a topology or set point, it will trigger automatically, like runs the load flow on this one. And when it runs the load flow, it calculates this value through. I will show you, for example, this one. Let's put a set point here. Instead of 5,000, I put it 600. Okay. I'm just simulating what could the owner of this battery could do, right? And then when I did that, you see automatically this value changed to 600. This is the results of load flow. And then that impact is shown here. So it was 3. Now we lost that 400. So it's now goes up. And then in this value is the exact value you see on here. Yeah. So I could have like manually changed this. Right, so you can okay, for example, I change the ampere, I make it like 187, for example. You could do this as well, but like then you see here it would change. Yeah, this one change automatic. I mean, like it scans it, right? So like it's actually come through the protocol that they're talking to each other. Yeah. Yeah, so it's the protocol between them. So if, for example, you remember we were talking about, okay, can we put a tag on it? So place tag, stop processing, okay. If I put a stop processing on this one, I change it here, set to 195, okay. It doesn't update. So that's the purpose of stop processing, so that some data comes. So it doesn't. The other thing is very helpful to use this. Okay, so I just remove the tag. Okay, as soon as I remove the tag, it might get the data from here. You see, automatically went to 195. The other I was showing load scaling yesterday to your colleagues, but like one of the basic studies you can do here, like let's say go to that MS01. So the value, all right, so let's say it's now 3.4, right? Here I can say increase it by 20%, let's say initial, whatever value it is, and it's in percentage. So when I add this, so it applies to simulation, right? Because it applies to that simulation. And I need to run a load flow there for when I apply this. Oh, sorry, I think automatically it did it. So you see, it's automatically did. Okay, I think when you do load scaling, there's some option, I think automatically did. Okay, so 4.2. So now it went to 4.2. And you have that alarms again. And now the next time active network management would run, it maybe wants to do something, but probably because it used all of the resources already, it cannot push it further, I guess. Yeah.
But could the ODS system can do the same?
Sorry?
Could the ODS system can do the same, like simulate the number of
Yeah.
low?
I think OTS, we also provide the network simulator, OTS.
Oh, yes. Yeah. This module is behind the OTS, yes. So this network simulator, if you, it's used for, yeah, it's basically the main core of that OTS for training, yeah. So you can raise this and see what happens and, yeah. Create alarms and stuff, right? So yeah, so you see when I run this again, initial state was 1,000. We already used 1,000, so we cannot use less, like it's the same. We cannot use it extra. We already use the flexibility of that. What else we have here? So exclusion list. Okay, so I just give you some hint of exclusion list. It's just that, and like it takes you to there. So you could say you could say, I think we closed this, right? So you see this one was not changed. Okay, so because I refreshed this, maybe in the previous one we changed it, but let's say we locate and we don't want to use this capacitor for whatever reason, so we can just right click and drag and drop and put a node, say out of order, for example, or something. There are a few ways you can do it in exclusion list, or you can put place tag out of order or do not operate. So these are the things that I was explaining yesterday. So there are a few ways to do that. Some people like to use in exclusion list. Some people like to use tag. The delta is, so this is mainly used by applications. So you don't see any like on the like what happened here. So you need to open this exclusion list. But if you put tag, it's also for operators as well, right? So
when you place a tag, the operator cannot control remotely. But when you like put it in the exclusively, just ANM cannot use it, but the operator can use it, right?
Operator can use it, yeah. And it's generally all applications, not just ANM. So if it's VBO, if you have another applications, then there's this. So yeah. So but like it shows like a here as well, like you see, like it says on exclusion list. And then like let's say you just change the node, or okay, you want to use it, you just remove it from that list. So profile library, we did profile assignment. You already, I think, familiar with profile assignment. We can have multiple profiles, and in one area we put one profile, in another area we put different areas. Okay, so probably okay. And the event summary is list of events for this specific application. Okay, so you know, like it is triggered on violation, it's triggered manually. When I triggered it, it sent issued command. You know, when we were sending command, you see, you can see all of these things. This is a filter of actual event summary, because you see here it says resource ANM, resource reason ANM, and substation Montana Sky. It's kind of like you could do it differently. You could go to here, view, and like you have summaries. Yeah, event summary here. So it shows everything, right? That specific one, it just with these filters automatically filters, it would create, and then it's easier for you to just analyze what happened by ANM, right? So okay, so these are some features of this product. Okay, so I close this one. And alarms as well, like if let's say something happened, yeah, it says, for example, partially completed, right? You see this and or like filter can be very like complicated. So and the it all uses and first and then uses or, so that's why we have all of this. So it's a bit yeah, but like at least you can just with one click you can get to that complicated. All right, so these ones, I think these are like normal things, locate, copy fit, blah, blah. So these are not very important. And also all of this that you have here, like you could see from here, right? So yeah, just depends on what you do, what you want. So I prefer some myself like to read the comment, because after a while you might learn that what it is, but okay. So this report, I think we covered this one, right? So we said, okay, what is it covered? So what is it done? already in optimal. So yeah, like this one now is running in the background automatically. We already send a comment, so it says already optimal. Now, okay, so now instead of 1,000, it says it can go up to 500. So basically is reducing it, like you were saying, like can it reduce? Yes, this time it reduced it too. And here, the value also depends on if you want to see here. So it depends on like you're on state estimation or not. A state estimation is periodic. So maybe we didn't get a periodic. That's why it shows 0 kilowatts. So it's coming, it will come eventually. But if you not patient, it depends also on the this configuration. You see it is updated and it's 500. So this is yeah. So this also sent by EVN. Okay, but in another call. This are like flashing means like it's producing. So this can change. So yeah, it's producing. You see, it's this load is actually 4 megawatts, and this is kind of like reducing that load for the upstream. So that's because we wanted to go to lower value on the feeder head, right? Okay. Let me go to the back to the my presentation to see. Okay, we explain this one. Okay, I explained this one. Oh, okay, so I forgot. So you could select this tree up here. You want to have more information, it gives like a bit of more information about the last one. Yeah, this is, yeah, we explained this one, right? So that's yeah, switching sequence. We did see that, and violations when we press this one. It shows all the violations for that substation. So yeah, that was explained. Flexible assets, flexible resources. Yeah, this is an example of like if you have multiple resources, like in the case you had just one battery on that one, but here you have the bin generator, battery, and a generator. In the merit order list, it was one, so it first used that one, and it like proposed. I mean here, nothing much changed because probably it was maximum already, and then for this one it engaged, and from 100 went to 700, but this was packed. The last one was packed and used anyway. So, but I mean, it doesn't also below the order on the below on order list. So that was two reasons probably didn't use it. And the engagement report, I explained what it is. And this is the details of that. The damage overview and then the details. Merit order list. I again explained what those means. Like what is the those. And this is like okay, why? Yesterday I was asked. You remember I was saying maybe we need two limits. One limit one is used for what I was showing today. This limit two is only used to trigger. Yeah, remember we said emergency. Emergency is the terminology for EVN, it's just level 2. So if your value is going to be that, in 10 seconds, it will trigger it. What is this one? When you have a state estimation, let's say this is a conductor, right? And then it has a limit. That limit, let's say, is 900. We can define as many as we want. So this system has 4. You can have 3 or 2 or 4. 5 is too many. And then the next one you can say is a percentage. The other one. So this is 100%. This is 10% of that. That's 20%, and so forth. So there is a configuration. We can say what limits do you want. And even it could be less than 100% because your rating is 100%. You don't want to reach to 100%. You say my normal limit is up to 80%, and this one is 90%. So these are configuration. Maybe if you have something in your mind, you can tell us, and we set up in the system for you. Yeah. So we can put a default value. Like, do you think it should be less than 100, or because some customers, these can change always, like it's easy to change, but like they play with the system and they come to the value later. But we put it for you where you can find this, where you can change this, so that you can.
Actually, default is still good so far.
Sorry?
I mean, default configuration so good so far, so I don't need to.
Yeah, you would change your mind, I would say. That's fine. It's just easy. Okay. Voltage limits. For lines and transformer is that one that I was showing. For voltage is not per element, it's per system. So, but you can say for this 12 kilowatts, your measuring voltage 22, whatever it is. You can define for that voltage level. It's 5% higher, and it's actually high, very high. 2 levels up, 2 levels down. You can also, if you have some numbers, we can write it down and put it for you if you want.
Actually, I grow it and send it to like Syria.
All right, we did. Okay, we put that then. You already know this. Okay. Yeah, for consumers, we don't have low voltage, but if you have low voltage in the, you see this is consumer and you have a contract. So this one, you select this and it shows it here. All right, so how EVN does this thing? So, okay, if you go model based, it's an explanation from model based. But like, if it's not model-based, load flow is, let's say, heuristic load flow. Like, it just sums up the number, right? The load flow executes first and check if there's violations or not. If there is no violations, first it disengage anything that we had before, and then simulates the load flow with those engagements. So if you have new violations, we need to engage more. If you situation resolved, right, based on the new state of the system, it will disengage those ones. And then calculates the violation after this. Now, the second, fifth one is engagement of traditional assets, like if you have voltage or like something you can switch or something like that, you can use this. Then again, calculates the violations, tries to resolve those based on MOL or contribution. So why this one is because if you don't have MOL, we can just use based on the contribution of that element. If you don't have priority, this MOL is for like customers that they have priority for devices. You can leave it empty and it tries to resolve it. But okay, we just, for your case, we just put one MOL, and then again does this and export the results. If it's, when there are like There's diagram in the functional specification. You can read that more. But like after all of this, it might resolve or partially resolve or not resolve. So it comes with three ways. So resolve the screen, partially resolve. It was amber. I was showing to you yellow and orangey.
But can we change a little bit harder, like bring those steps before those steps?
No. These are like the algorithm
Yeah,
already.
see, right?
Already algorithm is designed like this. I think I explained this one to you. I was saying that engagement lists are in the DR database and so why we don't disengage? Because there's no additional engagement. Okay, sometimes because this MOL list for some customer is dynamic. It might change over the time. Why? Because let's say you have a market price and this contributor play with the market. The price is going up and they say, okay, we're not going to curtail anymore. We want to keep our device not to be flexible. They remove it from MOL list, and if the device is removed from MOL list, you have to basically assume it disengaged. So that's another reason. Their new MOL has changed. So like previously was 1,000 and now it's 500. The value changed. It's not just adding new or removing. So because of that, we just disengage everything and we just try it again. For the order change also. So it's like we're going to use the less expensive asset. Yep. Okay. I think I verbally explained many of these. But yeah, just quickly, we do a lot of simulation to see what it's supposed to do, transfer load or send a command or blah blah. There is something that when you have limited devices, you can move one load from one to the other one. This is some like hard decision to make because sometimes the operators they don't want to move the by the system, they want to be in control. So maybe we want to use it only for also like semi-automatic, not for automatic maybe. But again, it's up to you. You can after a while, if you are interested that one, we can use this. Okay. I think I explained what is engagement based on MOL based on contribution. Okay, let's say you have the example we had kilowatts, megawatts on the feeder head. Let's say you have in the middle of the feeder, which you do, and PR is basically like it checks the upstream ones. It's one or two, like only the one that is engaged. Let's say you have like a T, you have one DR here, one DR here. So you have constraint on this one. It only try to manipulate this one, but the other one, right? Because it doesn't impact. So that's the contribution. So, but if on the same branch you have two, it might use the first one, or it might be use the second one, and sometimes maybe like always use this first one, you know. Yeah, I think from A&M it's this. If you want some me just give you some view of those contracts. Like, how does that look like for you if you want to populate in future? So this is an example of like the DER database, right? The one I was showing, like the class diagram and everything. So for example, this is DR type, it's end device, is DR group or something else. So this is that. And then you can say this is the ID of my which is should be the custom ID of that DR in the network model. The network model should exist. If you have it here, it's just reference here. And these are like, for example, minimum, maximum report, blah, blah, here. And then a little bit more complicated one is further bottom. So if I go to here, you can, let me just search for contract. Yeah, so for example, this one is a DER ID and it's contract. So the contract is grid services, and it offers 1,000 kilowatt, 156 offered power. This is the offered power I was explaining. So you can play, and it's positive. So, and number of calls, like it was in there as well. Like sometimes they don't want to play it too many times, so they put a limit on how many times you can play with this one as well. So, and so far, so it might be look a little bit, yeah, so complicated here, but like that's the input file for this. If you want to see this one on the system, am I disconnected? This one I sometimes get disconnected if I am not using it. But okay, I go back to here. The relationship between elements, I was showing those arrows in this. Let me see. So this relationship with the arrows there in this XML is here. So for example, it's between this. So for example, this DR table, it should have an attribute that says where it's belong to. So this is the relationship between those entities. Let's see what's going on here. So I have too many things open. Let me. Oh, I have it here. Okay, so. All right, so this is the DMD where your DMD is, okay. And then this is another machine which is called historical. I give you some SQL commands to play with this. Just get some ideas, how can you use it? So I open SQL Server. Are you guys a bit familiar with SQL Server? Yeah, okay, cool. So I just connect to the system. So these are all the databases that we have. This first one, I don't know if Faris had a chance to explain some of this. This is a query engine. It gets the data from like network model. The tables are kind of like dummy here. They are like views. They connect to the like a network model and they get the data from there. So I think, like, for example, if you want to see all of your fuses, you right click here, select, and shows all the fuses here, right? So and okay, so this was top 1000, because if you have too many, you don't want to show all of them, right? And you can select what fields you want, and you can remove and show only the one that you need. So that's, I think you probably are familiar with this tool. Okay, so for us, this database that we are talking about is DR repository, sorry. So I go to tables. These are list of the tables that we had there. Like, for example, DER is like all of those DERs. DER has part of the data, right? So it is the type, the maximum export, maximum import. So it's exactly like the XML I was showing to you, right? So XML, if you remember, we had minimum import, maximum import, blah, blah, in that XML. Forget about this data set and owns. These are like internal fields. Don't worry about like these like last three. But these one are the data basically we give through that XML for this one. And let me just go, for example, contract or okay, so this DR contract is empty, but okay. All right. Oh, this, sorry, I'm opening the wrong one. Sorry, not DPK. Sorry, I have to open basically this one. Yeah, so that's the contract number. It's similar to the fields that you see on the XML. What you need to do is sometimes you need to join these tables together. Okay, I got a bit more complicated query here. Maybe I send this one to you. You can try to manipulate it. So like I use the DR table, I connect to energy storage batteries, and then I check for DR group or distributor. So I put outer join because I wanted to combine all of these three. And then I was joining to type, contract, flexible consumptions, and all this. And I was just looking for one, let's say, element. And if I run all of this together. So for that one element that I was showing earlier to you, this is the battery, the rated power is this, and that's the full load contract. So we have 4 contracts for it. One is this one is full load. What is the difference between these two? So you see, yeah, so you see the start date is different. So 2003 to 2027 is from this 27 to 23. You could like have multiple contracts. Why? Because I said to you, like you can have weekends and weekdays. And this value here is like a day of week. It's like a bitmap. So this 127 means basically all the days, like, you know, like 7 days. If you want to have, for example, Monday, it's in the data, but in the specification, it tells what exactly which bit is bought. So you could have different value, but right now I put all days the same. So the reason I have 2 because of the start date and end date is different because I don't know, because of the season or because you
127, maybe just from Monday to Saturday only, because it's like binary,
yeah.
right? I mean,
Yeah, 7 bits. Yeah.
Yes, 7 Bitcoin. No, need check.
Yeah, it's all 7 days, right?
Oh.
Yeah.
Okay.
And yeah, so this one's yeah, so this one, for example, this is the generated generator one. You see this full generation, right? So we get four, and we have flexible resource. Probably I am missing flexible resources here, so I can have another query to show also flexible resources. I think I'm just grid services. Sorry, grid services. I have it here. Okay, maybe I'm not showing it. Oh, we have offered. Sorry, this offered is null. Okay. Yeah, I can provide this one to you to play with it. You can change it as you wish. So that's the first part.
So when we like update the XML file for the maybe like your system will like read the file.
All right, yeah, I'll show you where it reads from. So you need to go to another server. It's real time in this case. Ask me all the time. I need to just some. I'm using my phone
Why don't you use the Wi-Fi?
because they were told us not to use any Wi-Fi.
Oh, really?
Okay. Yeah, they say you right.
My company say use your phone. Oh, I don't know.
Because you scared your data will go through the modem or switch or something like that and can read your like data.
I think so, but yeah, because when I came here, I get a local SIM card, and I said like I have a lot of data in it, so it's very fast actually. It's very fast. Probably it's faster than your network. Okay, so this is the location of on the RT. I think Boana was showing you something similar, so you will be familiar with this folder. So see ADMS, executionary electric data, ADMS data, and import. So like if I want to update that, let's say I have file here, but the name should be import data. I should remove that underline too. And then I put it here every, I think 1 minute or 10 seconds, it reads it. And then when it reads it, it puts it here, like, and then you can see the last time I loaded data, it was this, okay. I can do one change and put it there, and you can see what would happen if you want. Yeah.
But when you put the new file to this folder, do you need to like run all the application to import to your DB?
It reads it and loads it.
But could I know more for the process because but you go back to this one later. Oh, actually, maybe ADMS. Because the last foot, I just see Farhan show that you have a lot of TV like the TBF5.
Yeah, TPF.
Yeah, it's some folder, but I think your system will separate the data for firstly for real time. They will like
Yeah. That's
from
different.
the
Yeah.
TBF5.
TP3, I think.
I don't know. That.
So
That's
sorry,
fine.
just are you talking about like this one?
No.
No. But okay, this location is also in some this by default goes there, but you can also change it to some other location. You can put like, I don't know, if you want to have another file location for this, there is like a configuration you can change. I think I need to find where exactly is that configuration is. Like in one of XML configuration you need to change.
For some like real-time data like alarm event, can we like query in the historical data for real time?
Ah, that's different. That's different. But this one is for import. For this specific application, it will look at this and does it like this. If you want some like query, are you talking about like you want to see the where the events gone, right? You want to query, okay.
Không, nó có cái IC là 2030 dùng cho RAM á, chứ không phải một cái từ giống như mình.
Thì đó là một protocol thôi, đâu có gì đâu.
Kết nối với lại
Quan trọng muốn chơi Javix nào thôi.
cái người thông tin mình đã chuẩn bị thành cái chọn nó cho cái pin mặt trời hay sao?
Có ai quy định đâu, đâu dám quy định đâu. So please continue.
Okay, yeah. So this is that's if you want to see like for example like you were asking about event summary and all that, they are kept in the database like here.
I think it should be time saving. Maybe.
Is it on time series? Oh no, those times okay, so this is operational activity. So let me see. Yeah, these are event summary here. But this is event summary, you know, like we were like, and you can just, this is top 1,000, you can put a where condition. Okay, I want to do it, for example, time, I don't know, like you, like say, okay, yay. Yeah. You can I don't know, like you can use this for event summary, but we have different like area. Like if you want, I think what you're saying is time series, like you want to see the points like when they are changing, right? So they are stored on these ones. This is a bit difficult to, some of them is a little bit more difficult to get the data from. You need to know what it is and just explore it a little bit. But so this is from like, let's say the trend. I was showing the trend for you, like when the analog value changes over the time, they will be stored in this one that Sirnia was saying that like database time series. We can
like query immediately after the stated change from the real time, or we have to wait for some.
Yeah, a little bit. It's not like millisecond, maybe a few. I don't know. It depends. I think it's quick enough, I would say. Yeah, you don't need to wait for 1 hour or something. If you're thinking of 1 hour, maybe a few seconds.
Because in our existing system, we have to wait for about 5 minutes.
Ah, okay.
Yeah, they separate two kind of TV. It's almost the same with the your file. I think so because you also have the not DBF, maybe MDF file.
Yeah. So two things like things like this, like that when the analog data changes and stuff. So some part of data is in the cache. When you look at like when it trended, maybe it's quicker to come from there. But sometimes go to the time series. Time series it puts in a queue and just puts them in this. And like in your system, in this system that we're gonna have for you, it's gonna be in the core. We can have a DMZ historical database in DMZ. I'm not sure if we have it for you because some customers, they want it. And then that replication between those two, it takes a while, maybe I don't know exactly how long, depends on the system. So maybe 5 seconds, 10 seconds. But if you look at the core database, the time series, it's generally quick. So like I can order, for example, by time, this just one thing. This is in UTC. It's not your time, so time zone is not displayed here. You know. So this 8, you need to add 7 because Vietnam is 7 hours ahead. So it's 15:06. Like now it's 7, right? So the last time it was 6:43. And if I do it again, you see it refreshed. Yeah, that's pretty quick. So like right now, let's see what is the time. So 29. I do it 27:29. 7:29. It's like very quick. No. Just 0 second. So 42, 43, 45. Okay. Oh, this one is for 5 seconds. Yeah, it depends. Yeah, because maybe the system doesn't do anything. Yeah. But like it's very quick. It's very refresh. This is 55. Yeah. Okay. Yeah, you can. All right. When you're here, I tell you, like for forecast, we're gonna come back to this one. We are using this aggregate data. Aggregate means like, okay, so like you get data every single, I don't know, seconds, whatever, like it just comes as it is, right? And it goes to that collect table, and then averages based on the configuration. We say every 1 hour, average 1 hour. So this one is AGG hour. So like for the data, we do averaging for some quantities and for forecast, for example. Yeah, there are lots of things on this one. I think, yeah, we can. I think I just want to go to. Is that enough? I think we can go to the next one. Yeah. All right. It's. I mean, we can talk about this system for like a few years. All of the systems are like that, right? You have experience with many things, but this one is also the MOL. Say MOL is a bit simpler. So this is, we need to just give the ID of that. And you remember, like we had 100, 100, 200, 500. So this is number 1, number 2, number 3, number 4, and so far, so forth. So like this one is our favorite one that was showing in the user interface, if you remember, right? Do you get what I mean?
Yeah.
Yeah, that's 1 and 100. Number 2, order, and 100. And so this one is, if I go to, where is my, I copied that one. Okay. Yeah, a lot of security. If I don't log in every 15 minutes, I need to put the passwords. I think you have the same, right?
Yeah. 10 minutes.
Oh, you.
My side.
Now I forgot my password. Slow down. Okay. Yeah. Control V. Okay, so that I copy paste that one. So this is, yeah, that battery. So I have to. That's, if you don't, when you create the database, when you add in the network model, it creates that like generated like automatic generated kind of things. But some customer they use their own like to make more sense of it. So up to you. I think you can make some, but you need to make sure that's unique among your systems. So it's a bit difficult, yeah, but like it makes life sometimes easier when you're troubleshooting or look at different places. I suggest, like, for example, customize it to be something combination of substation and the name of this makes it unique. That's my suggestion. I would always like try to do things to because this custom ID is very important. It should be unique, and like this one, it could be like same. It can be multiple of this name, but that only needs to be unique with the parent. Yeah. Okay, so I think we finished A&M. So new application. What war flexibility? What does that system do? Okay. Um, when we have lot of renewables and stuff like that, we want to engage them as much as possible, right? So, and then we want to avoid like capital investment or like, let's say you have more load because you have new customers or people have new devices, do you expand roads, so those type of things. So with this application, we can kind of like adopt your load management on for the network level. Like when I say network level, it's from substation upwards. So normally you want to say, okay, I want to reduce. Your transmission company tells you, all right, keep your loads below this value because I have constraints, I have problem with generations. They give sometimes order, I don't know, like to you that, okay, keep it below this, right? But this is in like all times when they order such orders, so they do load shedding. They drop some loads from some customers to mitigate to below that limit, right? Now, if you have flexible load, we can say, okay, put more solar or put more battery as a generation, and we can mitigate from top. And going forward, I don't know is a problem in Vietnam or not. In many countries, like for example, Australia, they have too much generations. Sometimes they say, it actually it's reverse flow, like it's not even like 10%, it might be 20%, 30%. And when it's too high, it destabilizes the network from the sub-transmission network. They want to also, not only from top, they also from bottom want to make it between two limits. And that could be on the system level from like, I mean, in your case, you can have one substation, but let's assume that you have it for all of your network. It could be like a region or the whole network. So, so it can be applied for the whole network, for region, sub-region, substation, transformer areas, and feeders as well. So this one, it has, okay, we need to use simple network connectivity. Flexibility for the day ahead. So this also look at the future because normally like you can have a forecast and then you want to say, all right, when they tell you you need to keep your production between two limits, they give you for the future. They might be in next 2 hours or next 24 hours. So this application goes for up to next 24 hours, right? So and uses those forecasts plus the flexibility we discussed this morning to see what it can be done for the system. And then when it hits the limit, so it sends appropriate signals for the DRs. And similar to what we explained this morning, it can support exclusion list. And also, if you have load flow, it can also do calculations and look after the load flow. It doesn't send any command that impacts your own network. This command was sent by, transmission company, but you don't want to also overload your limit. So, what is the output of this? Forecasted demand and available flexibility of demand on the level of, again, whatever level we used before. So there is some visualization of what would happen, and then you can submit the screenshot. Let's say, application says, okay, in like 3 hours from now, you need to cut the power from this, increase the schedule, and then you can send it through. Request basic can be sent to third party through individual resources, right? So that's another thing. How does it look like? I will show you on the system as well. But this is my North America region. Let's say you have like these regions and substations under this. We aggregated for each time in next 24 hours. We said, okay, this is the forecast. This yellow line is the what will happen in future based on like the forecast. Yeah, forecast. It could be, and then this is my flexibility, so I can generate more, and I can bring this down, and I can go high, so I can add more. So, and here the line is the command you put here. You can put minimum demand and maximum demand. So like two lines. So when you put those two lines, it will calculate based on this. And then you, on the right hand side, you have all the flexible resources under that substation. And it will show how much flexibility we have to increase or to decrease. This is on the increase. And so, for example, this ESKK1, it's like an energy storage on the feeder KK01, probably it sponsors power, it is one of those. And at that particular time that you're doing here, it has 26. Okay. So yeah, demand increase, demand increase, demand decrease. Maybe I just see if I. Now, let's say I want to do manual control. In the manual control, you see these are okay because these are below my line. And that's the top line and this is the bottom line. So you want to keep it between these two. So user says, oh, okay, this is and also this is class. I will select this one as well, right? And then you select all these four, and then there's like a button you can select, and this time is automatically selected between 6 p.m. and 10 p.m. And you manually say, I want to decrease 4 megawatts between these. I have flexibility of 4. I can decrease 4. But you can say less than that 4. It's up to the operator. They can say, all right, so here is not like that much. I have only 0.7 megawatt. I think that's for 1 point. You can put different values as a user. And then these are the constraints I want to check when I do this. And it's for load flow. If you don't have load flow, you don't select this. And you press the schedule. What it does, it uses all those elements here and creates a schedule at different times. And then if it is prepared, like here you have 10 commands and 10 devices to be sent command, and you save it and then execute it. The schedule will be sent to this individual one, and they need to absorb the schedule. It's like similar to what we talked this morning.
That's mean how we have to like communicate with the system by the 2030. the protocol. Right.
And this is like theory. Okay. I can show you on the system as well, but okay. Yeah, we have this bot flexibility, but we have var flexibility too, but like here.
Tôi nghĩ tuần sau là em biết là làm được vì đang có dự án cái tuần thứ hai tháng tư mới được. Dạ. Thì không phải tiếp mà là cái khóa học đào tạo người ta bay vào bên đây người ta đào tạo liên tục. Dạ. Tới chắc giờ nghỉ trưa 12 giờ được. Dạ. Giờ nghỉ trưa thì được. Dạ. Dạ, dạ, ok. Chưa thì thoải mái, chưa thì thoải mái. Dạ. Dạ, 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 dạ. Nếu nhờ mấy anh em thì chắc 12 rưỡi rồi. Dạ, dạ. Dạ, dạ, dạ. Dạ. Rồi, dạ, ok. Sorry.
That's okay. Yeah. All right. So I'm just sorry. I opened this bot flexibility and then I was like playing like around. So like I was selecting this region or this station. So you see, for example, if I select Texas Rose, this is 40 something. And then if I go to like it's cumulative of this, and it will show the different years. So this one, for example, I don't have any limit, but these are the one that I can have available to decrease. Basically, it's just generators, and this is to decrease. It's like flexible load, let's say. And I can say, all right, so you see this yellow line here. So maybe I put it like, I don't know, 165 and press enter. You see this line goes there. In some cases, I can resolve it. Some cases, I cannot resolve it, right? So it's in this case, let's say I am interested on this one, okay, or whatever, like this one, probably. I can select and just maybe this one doesn't make. Let me just put some value that is more meaningful. I put 180. Just if I cannot meet that, I need to do something else, right? Like here, only these two are unresolved. So I select these two, and you see this value change. I can increase here, and I can say select this, click on this one, and I have 6.8 in total flexibility. Do I need that? Okay, I need 5.66. Okay, so I can say, all right, I don't need 5.6. I don't need 6.8, but I need to do this. And I already selected for this one, and I say schedule. And when I schedule, yeah, I would need to get some results, but maybe some of these elements, if they don't have that signal for transaction, it might show empty. Like for example, this one is, I think probably is because of that. Maybe I have it on this one. Let me see. So you need to have the right data as well. So I put 40 here. 6 megawatt. So this 6 megawatt, yeah, you don't need 6 megawatt. Probably 3 megawatt is enough. It just needs to be more than this, right? Yeah, so it will, I mean, this one also doesn't show, but yeah, I think there are some data problem here. But it is kind of, if the data is correct, so if you have that signals, it would show like a curve like this one, right? And then you can save it and run it. So I check that. Maybe I need to, let's see, let me try somewhere else, because maybe that Montana Sky that we were playing with this morning, maybe has better data. This month.
So what if like we just send the schedule, but we change the mind and we want to use the other source. So could we send the reject schedule to this device?
To another one?
No, to that device. For example, like at 1 p.m. we just send the schedule to this device A. And after that we change the mind. We want to send to device B. So can we reject the schedule?
Yeah.
For
Yeah. So you can rerun the schedule and it updates the new schedule, sends it. Yeah, it's already, the previous one already sent, like in the interface you already sent. So you can create a new one and then send again. Yeah.
So I mean, no, I just want to reject the schedule, not send other schedule for the device.
Check. You want
reject.
No, it's like a bone. You already sent it. So it's already gone, so you cannot back.
You mean that once we send the schedule from our system, in the system can we see what we schedule that device in our system? The set point schedule, right?
No, in the other system, we can see only our system. Are you just, can you explain the question? Maybe I didn't understand properly.
Yeah, actually, because for example, you have two DER can like degrees, right? When I send the schedule to this MS of 05 and just a half hour later, so I change my mind. I want to send this new schedule to the best office. To this one here. So
okay.
Could we like send new schedule or some command that can reject the old schedule for the MS05? Because it's stored in that device, right?
Okay, so what you can do, okay, so what you can do, let's say for this one, there are two devices here. So this is for the whole feeder, right? So this is total of these two. So yeah, so this 40 plus 0.4, 0.5 is, let's say for this device, I schedule like 0.4 and I sent it for 6.9 and I schedule. Okay, when this is created, like this one. This one is actually working. This one is a good example. So you save it and then you send it. When you send, it's like from interface is gone, right? So this schedule already sent. So what you can do, you are now, okay, you want to send it to this one. So you can decide, select this one and send 0.4 to this one, okay? And then go back to this one and say, okay, now I don't need to do anything for me. You can put 0.
But when you click the schedule again, you will you see the previous one that we already scheduled it? I mean, let click, yeah.
Oh, the schedule, yeah, it goes it to the array. Is that what it says? There are different questions, right? So you want to see if the schedule is observable here. So if you sent it through here, so you can see. I didn't send it through, but like it would show it here.
Can you see the schedule?
Yeah, I didn't send it, but like let me see if I can send this one. So because we don't have interface as well, that's another problem. Okay, but let's see. This one is okay. So okay, let me just. Okay, this one is already automatic. Okay, so probably I should have turned this off and make it semi-automatic. I should show some execution. And then yeah, so it's not showing it, but in theory, yeah. So in theory, you could yeah, see here. Okay, it shows it here. Yeah, so you can see in here. Yeah, it shows it here, and then you can click and see what happened. And no, you see it doesn't show it here. Why? Because not use all of it. In the previous one, I used all 0.4. It doesn't show it anymore, right? If I want to,
but could we check the device that received the schedule or not? Have the device received the schedule or not?
because yeah, here.
So
Yeah, I sent 500 like at 3 or 6 or 7 or 7. It's sent there. So this is the record we have. You can see here as well.
why is that? The value, where's the value 500 come from? Because you said 0.4, right?
Ah, 0 point is the flexibility. So sorry, maybe this is the wrong signal, wrong device. Okay, so this one is, let me see. 400 was their flexibility. Maybe it was using 0.1. And okay, so let me just go to this. Locate, sorry. Yeah, because it already had 100 kilowatt before, right? And we added 400 to it. It's going to be 500. So the real-time data you see is 100, and we added more because that's why the flexibility was 400. For this one, if you look at the contract, I think it's 500 up to 500, and you have only flexibility of 400. So
But
that 400 was flexibility.
We are going to decrease the demands, right? Not degree. You have degree.
Yeah. So this one, what you can do, you can say, all right, I want to get that 0.4 flexibility back. You can say, go here.
For the degree top over there, you need to this one.
So to this decrease.
Yeah, because that.
This is disappeared. Why disappeared? Because there is no flexibility
Yeah, I know
anymore.
that, but this the degree the demand. So you like this is the battery, right? So you when you want to degree the demand, you make the battery inject the power to the grid, right?
Yeah.
So they have like some negative value, not like at more 400, right?
I think negative value mean battery charge.
Battery discharge.
Discharge should be positive, right?
So you can see from here, right? Okay, so maybe I just move this one ahead. So just want to see what it is. You see, it's charging and it's showing this. So positive means like injects power to the network.
Discharge.
So this one is actually has 500 as a like if in the contract. So it has 500. So we had 100 already, and it shows flexibility of 400. So that's why. Okay, we said we're gonna use that 400 in that 2 hours. Then what happens in this flexibility? You don't see it anymore here because you already used that everything. Yeah. So now you want to say, I want to get that back, right? You want to get that back. I think that's what you want. So you could go to here and it's that device, right? And then you can say, all right, I asked you to increase the demand. Now I say decrease demand. Okay. But maybe I should have selected the time. I think maybe, let me see if I did that. Yes, I did it already. I think I scheduled it, and I think it was automatic, I think last time, so it was applied it, and now you should get it, I think, back. I think it takes time, but yeah, you can claim it back this way. So you can only go and you select and just do it like this. Maybe I didn't do it. So let's select execute. Oh, let's wait a little bit, I guess. Yeah, so you see it came and it basically it keeps both of them, right? Now, yeah, so it keeps both of them. When I refresh this, that 04 is back. Yeah. Your battery needs to interpret the new one because you already send a schedule like already, and he gets a new one. Say, oh, forget about. So yeah, that's the way to do this.
You can like write it to the schedule that we set. Can you try this? Negative.
Negative 300, yeah.
Why?
Because now is 100 and we ask to reduce y 0.4.
Oh, I mean like last schedule you just send like they have to increase the power to 500.
Yeah, but like imagine if we sent it already, they would have sent
so
decrease.
at that time they have to like inject around 500, but after that you send new schedule to degree like degree like 400, so that's what we go from 500 to 100, right?
I know what you mean.
I don't think it's like that. It's the baseline is the demand. If you send
The real time.
500 from the demand, right? And this is 400 below demand, something like that.
Yeah. You know what happens when you send the first one, right? They increase 400 in their schedule, and then you say, "Oh, bring it back." So this 300 is the delta. It's just it takes it. It takes it. It takes it from this 100. So this is like 100 already. You said bring 400 down. It goes to this set point because
The baseline is 100.
yeah,
Right.
because real time is 100, right? So
Baseline is 100. So
But in reality, so what like the action from the device they have to do, like for the system they send two schedules. So how could
yes,
like,
we assume that they did the.
with the final schedule they follow for the operation.
I know what you mean. I think, but like we cannot say not to do. I think previous one. I think because like let's say you already sent that previous command, so from 100 it goes to 500. So they should have changed it, and now we take it back. If they had changed the set point, it would be back to 100 because they didn't do the first one. Now we say reduce. I think the
But the
operator.
system have to like erase the first schedule on the
Maybe there is a way to erase it. I don't know exactly. Probably maybe I follow up with that question. So can we just? I don't know. I don't think we can say forget last command we sent to you. I will check that, but I doubt we can reject the previous one we sent to you because let's say I think it's like you're thinking of a bank. You gave the money and say, okay, give the money back. Then they have the record. I give the transaction back. I know what you mean, sir. But maybe our system doesn't work like that. I think it assumes, all right. So you say 0.4.
We're not like some situation like war or something like missile or press the button, red button or something like that, because it's just the operation. So after we send the schedule, maybe we can like recheck it or get it back or something like that.
I think
Like say like before when we said like, oh, okay, I'm set like the wrong device, so I recheck this. Just cancel.
I need to double check how that happens. Like probably maybe in semi-automatic, you have the chance to review the command and see what's happening.
you send the 0 to the schedule, ready? I mean,
Okay, maybe we can do that. So let's see if I send a 0 to this, what would happen? Okay, so select this. Yeah, maybe I was thinking about this. I think it takes a while to share that value.
I think it's by on the like
sometimes you quickly
ability
schedule
of
it.
the device. How many schedule they can store in the device? If only one, they like just override the old one. But
Yeah, I think it takes a while to apply this. I don't know the answer. Can we make it 0? Okay, so if it's 0, I think
But by the signal, even by the signal itself, I think you can manual override it, right, maybe. I think it's the same as the interchain.
Yeah, you can edit here. So
Yeah.
you can say put 0 value for all three.
Yeah.
That's another way. Okay, maybe we can do this. Do you get what we did? So here you can just control. And then when you go to edit, so but you need to select this one. So time so should be 6 p.m. Okay, 6 to you want to be back to 100, let's say whatever value, I think.
It's not correct. Sorry.
Oh, we went to next year. I
This
think
year.
we cannot just do this, but maybe I just
I think we just like
the date is like automatically goes to tomorrow. It's my God.
Yeah.
Okay.
Hi.
Yeah. So you can this way, do this way, I think. But you need to remember what you want to put.
No, I don't think so because it's such like a signal for supply purpose, not for
Yeah.
domain.
That command to the DR. Basically, when you do the one flexibility and you get the array, set point will send to the device for this signal. So, the signal is scalar signal, it will be connect to the DR and send the array schedule to the DR.
So you mean like when we set this schedule, it's like send
Control that signal. Yeah. Finally.
Yeah,
What
yeah.
I
So
understand-
when you apply to this, the next time because interface reads that signals. But I need to check how often it looks at the signal. Maybe it's periodic. So I need to double check that. Like, yeah, but it is makes sense that to be like that. So that's why you override this. You can actually, without any application, you can create a schedule, right? So even you don't have any application, you can just yeah, write your own schedule and send it to them like this. Okay, I will check how you can say, all right, sorry, I did the wrong thing and I just want to go back to what it is. But all right, so yeah. But like if it's, you see, it shows S here. So this one was semi-automatic. When S and the semi-automatic, you retrigger because this, to be honest, this one is used only like in like critical time, right? So when you have order from transmission network, you want to do that. Maybe you just want to do it semi-automatic. And then when you do semi-automatic, when you retrigger, so it creates this one here. And then you observe and see which one you want to do and select the one and then execute that. So maybe, yeah, maybe it's the better way to use semi-automatic if you want to have more control on like what is sent. But yeah, I will check that how you can say reject. But yeah, I can. Two things I think I need to check for you. This morning I was like looking at the hosting capacity as well to provide some explanation to you. But yeah, this one is I will check.
And one thing that we need to be clear on, so for the array signal, the schedule like that is available only for the DR which support the protocol IEC IEEE 2030.5 only.
Yeah, schedule is like currently for Yeah, that's
Yeah.
right.
So basically, we need to be clear because of this project, we might not have the DR under protocol 2030.5. So the schedule command like that, it might not available to your DR at this moment, but
nó có đề cập vào cái giọt nước này hay không bà con?
Thì biết rồi đó. Tăng chỗ là nó chứa được bao nhiêu lệnh nãy giờ em thắc mắc. Như 3 giờ anh đổ lệnh tăng, anh lại gửi thêm 3 giờ anh đổ lệnh giảm thì nó làm gì? Nãy giờ đang hỏi như vậy.
Yeah.
But did you have any like real device group from this protocol?
in the device that support this protocol, right?
Yeah, but
In Australia, we have.
have you worked with like those devices before?
IEEE 230. Are you talking about this protocol?
Yeah.
Yeah, we have some customers like in California, PG&E. They develop many of these softwares like for like America, Australia.
But have you tried this one like 3 p.m. set in week 100 and after that we set 3 p.m. also but degree 100?
I need to check. That's why I don't have the information for that one. I need to check with my colleagues if that situation they ask and there's a solution for that right now or not. So we'll check with them. Yeah.
But maybe they like put the schedule inside the array, so when the schedule comes first, they just run this command and after that they run other commands. So maybe they just degree 100 and after that immediately they degree 100. Maybe
Yeah, that's okay. Yeah. I know what you mean. So we have like something like compliance, DR compliance, this report, which I was like trying to explain it the other day, tomorrow or something. Like when you send a command, maybe they don't follow. Like, yeah, so you even like you send a set point, even real time, they might not follow. And then this compliance report would check that, okay, you send a command to change. It shows the one that. Let me see if this one works, for example, for Montana that we did today, Montana. Because we sent a few automatic commands for this, if you remember this morning. So yeah, this report, like for the devices that we have, it says consumption, generation, and blah blah, and I think you can do some filtering to find out like when they didn't actually apply that, but like all of the commands and stuff like that, it is in this report. So this one, see, out of compliance is 0, so it's probably it followed whatever we said. Okay, so that's why it's 0 hour. And it accumulates based on the hour. Like let's say you send 3 kilowatts at 10 a.m. they didn't apply it for half an hour and then apply it later. So this is kind of like calculus, how many hours they were out of compliance. But this one, I think, because we were using this network simulator, it actually applied, and so it doesn't report anything bad. But yeah, so we have some tools here. But yeah, if it doesn't do it, I know the problem, but like nothing we can do. Like what would be the suggestion of like you need to send it again, and I don't know if some companies they use this compliance report to go and talk to them to say why you're not following our orders. Okay. We can discuss that further, but yeah, today I think for what I wanted to show you, I think I covered. So I have 2 questions to follow. I see when I can have the answers for you, and then do you have more questions for today or?
So for me.
No? Okay. All right. So I stop.